Am I audible?
For deal, can we also cover a bit of gravitational field cutting off? Either can you know as well.
Okay. See, gravitational field.
Can you hear me?
Yeah, I can hear you now. You were saying something about gravitational field. You want to cover that first?
Yeah, can we? It's like a really small topic, so.
It is the space around the any object where its gravity or gravitational effect can be experienced, right? So, have you read about gravitational potential and gravitational potential energy?
Yeah.
So, what do you know about it?
It's the energy that like the Earth has or any planet has or any object has.
Uh, okay. What do you understand by the term potential energy? When we talk about potential energy, it is the energy possessed by an object by virtue of its configuration or position. And how does an object maintains its position in a field, right?
Yes.
Fine. If I have any object which is placed at certain height above the ground and I want this mouse to be here only, but I don't want to give any support to this mouse, then this mouse has to do some work against the gravitational force of the earth, right? It can stay here in the air. I want this to be freely suspended in the air, right? So if the mouse wants to stay here at this position, then this mouse has to do some external work against the gravitational force exerted on this mouse by the earth, right?
Yes.
Then that work done is your gravitational potential energy.
Okay.
The work done by the mouse to stay here at this height above the earth's surface so that it doesn't fall down is the gravitational potential energy. This work done is the gravitational potential energy done by this mouse.
Okay.
Okay, this is the basic, concept behind it. So I'll go through first your book VC so that I can give you the lecture that which is there, the topics.
It's okay, miss. We can do gravitational energy of field in the next session. We can start with electric.
Okay. So the topic here is electric charges. So what do you know about electric charges? You might have read about it in your previous classes, lower classes as well.
It's just movement of electrons or negatively charged thingy, negatively charged particle.
So how do we say that whether a given particle is positively or negatively charged? On what basis do we say this?
It states negative. The other one is proton, one is electron.
We say that proton is positively charged, electrons are negatively charged, right? So basically positive and negative are the terms that we just give them. We give electrons the term, the negatively charged particle, and protons as the term, the positively charged particle, because they have different electric nature, right? So one is positive, other is negative. So the first topic here is electrostatics, or we can say static electricity. The word statics means
I don't know, miss.
see, static word we use for anything which is at rest.
Which is what?
Which is at rest, which is not moving. Any object which is not moving is static. And electro word has been derived from the word electra, which means charge. So if we talk about the charges which are at rest, then it is electrostatics. So here in electrostatics, we study the charges which are at rest, right?
Sorry.
So, no problem. The branch of physics that deals with the study of electric charges at rest. So it is that branch of physics where we talk about the charges which are at rest.
Okay.
Okay. You want to write it?
Yes, I'm writing it. Give me a second.
Make a separate notebook for what we are doing here in the class, right?
Yeah. I do have one. Is this meeting getting recorded, miss?
Yes. You want this?
Yeah, can you also send this so I can revise this during exams as well?
Yeah, fine. No problem. I will.
Thank you. Yes, I'm done.
Okay. So how do we define electric charge? See, it is a fundamental physical quantity. The basic physical quantity means any quantity which can be measured is physical quantity, right? And because of this, electrical and other related effects are produced in matter. Electrical effects means here that suppose we have a charge, right? We know that like
Yes.
charges repel, unlike charges attract, and there is a field around the charge where its effect can be experienced, right? So
Yes.
electrical effects and other related effects. Other related effects may we can consider magnetic effect of electric charge. If a charge is moving, then electric current is produced. And wherever there is electric current, there is magnetic field because current carrying conductor produces magnetic field. Right? So when we
Yeah.
talk about electric charge, we talk about both the electrical and magnetic effects, electromagnetism as well, because charge,
Mhm.
movement of charge is current, right? Rate of flow of charge is current, and wherever there is current, there is magnetic field associated with the conductor, right? So it is a fundamental physical quantity. The definition is due to which electrical and other related effects are produced in matter. Second definition, the same definition, it is a quantifiable property. Quantifiable, in the first definition, we had written physical quantity. Physical quantity means it can be measured. In the second definition, it is written quantifiable property. Quantifiable property, again, we can quantify it, we can measure it, right? How strongly
Yeah.
an object is affected by the electric field. So if you have a big charge, right, then
Mhm.
it will have a stronger electric field. It will, other charges will experience stronger force of attraction or repulsion because of the charge, which is quite big, no? So
Yeah.
if the charge is quantifiable, means that how strongly an object is affected by the electric field. This is another definition. This definition I have taken from your book, VC. The first definition was there
Okay.
already there in the PPT, and I have changed a little. So I have added one more definition to it so that you can understand what is written in your book as well. So how do
Okay.
we
Just give
measure
me a
electric?
second.
Because we are talking about that it is a physical quantity, it is a quantifiable property. So we can also measure it. And what is the unit
Mhm.
of electric charge? Do you have any idea?
Just give me a second. I'm writing the
Okay,
definition.
please write.
Yeah. What was your question?
What is the unit of electric charge? Any idea?
Uh, Electric charge unit. No, I'm sorry. Don't.
Unit of electric charge is Coulomb. It is
Oh.
by a capital letter C. And this is the
Oh.
unit of electric charge. We can have C.G.S. In C.G.S system, we have another unit, another name, that is statcoulomb. Statcoulomb is not in your syllabus. You just have to deal with coulombs only.
Yeah.
Should I move to the next slide now?
Yeah. Yeah. Yeah.
See, we have a question here. You can read the question first. So what do you know about charge interactions?
I know that like charges repel and opposite attract.
What if we have a neutral object and a charged object, then what?
Oh, so neutral as in isn't negative or positive. It's just
Neutral means neutral. It has no charge on it.
no, we haven't been taught about that.
See, if we have like charges like positive, positive or negative, negative, of course they repel. For unlike charges, one positive and other negative, they attract to each other. But what if we have one neutral object and other charged object? When we say charged object, then charged object could be positive or negative, right? So
Yeah.
neutral objects are always attracted towards charged objects. They're always attracted towards charged object, right? Because see, if a charge is positive, what does it mean? It means that it has more protons than electrons in it. It doesn't mean that it doesn't carry electrons at all. It has more protons than electrons. If a charge is negative, it means that it has more electrons than protons, right?
Mhm.
है ना? नेगेटिव का मतलब क्या है कि उसके पास इलेक्ट्रॉन्स ज्यादा है, प्रोटॉन्स कम है. इसका मतलब ये नहीं है
जी.
कि प्रोटॉन्स है ही नहीं. It carries both the charges, but it has more number of electrons in it. Positive means it has more number of protons in it. And in case of neutral object, it has equal number of protons and electrons, and that's why the object is neutral object, because positive and negative charges cancel out in pairs, no?
Yes.
So in this question, we have, look at this figure, case 1. You can see the balloons here. A, B, C,
Yes.
and in another case, this rigid supported two balloons are there, C and B. So it is known that balloon B is charged negatively. So we have to find the charges on balloons A and C.
Yes.
B is negatively charged and A is attracted to B. So from the first figure,
Yes.
we can conclude that A can be either positive or neutral, because both positive and neutral object, they get attracted to a charged object, no? A negatively charged object.
Yes.
Are you getting what I'm saying? Please repeat.
Yes, yes, ma'am. I'm just writing down what you've said.
Please repeat.
Sorry, what do you want me to do?
Whatever I have said, please repeat that.
You said that positive charges are attracted to each other. Those are protons. In protons, there are more in positively charged object, there's more protons than neutrons. That
No,
doesn't mean that.
about this figure,
Oh, sorry.
about this figure.
Oh, in this figure, you said
Hmm.
that A is either neutral or it's either positive because B is negative, and C is positive and B is no, C is also negative because B is negative, so they're not attracted to each other.
Repelling, yes. So A is either positive or neutral, because both positive and neutral get attracted to the negatively charged object, right? Unlike charges attract, and neutral object is also attracted towards the charged object. While in the second figure, we can see the balloons are repelling each other, and hence, because B is negative, C has to be negative.
Yes.
And now
Okay, I
look at
get that.
this.
B is negative, A is attracted to it. That means it's either positive or it's either neutral again. A and C are not repelling each other, then A has to be positive and C has to be negative.
They are repelling, so they're like charges, no?
They're repelling. Oh, yeah, so sorry, C is also positive then.
Yes. A and C both are positive in this case. So from the first figure, we conclude that A and B will, because they are attracting each other, so A is either positive or neutral, but we can see that A is also repelling C. So from
Yes.
here, we can conclude that A is not neutral. A must be charged, right? So it is positively charged because it is repelling C.
Okay, I've done it.
Okay, great. So polarity of charges. Polarity means?
Polarity means, give me a second.
Kinds of charges.
Sorry, what?
Kinds of charges, types of charges. So there are two types of charges, positive and negative. This we have already discussed. So positively charged objects they possess more protons and electrons. We know about it, right? Because whenever an atom loses electrons, it requires positive charge, right? So it has more protons in it, while negatively charged object possesses more electrons than protons, because you see that when an atom gains electrons, it requires a negative charge.
Okay.
See, whenever an atom loses electrons, then because electrons have some mass, right? So mass also reduces. But if an atom gains electron, then mass is also increased at the same time.
Yes. Give me a second, I'll write this down. Okay, I'll do that.
See, what is the mass of an electron? Any idea?
Mass of an electron? No.
It is 9.1 into 10 to the power minus 31 kg. So every time when an atom loses an electron, then the mass of 9.1 10 to the power minus 31 kg is reduced, right? And if an atom gains it, see, when we talk about positive and negative charge, we only talk about electrons every time. We do not consider protons here, because protons are present inside the nucleus, right? And electrons are present in the
Yes.
shell, so we can easily lose or gain electrons. They move. Protons do not move. They are within the nucleus, the boundaries of the nucleus, right?
Yes.
So we know about the charged parts of an atom. These are electrons and protons. So charge on proton and electron they are equal, right? The only difference is of the sign. They are unlike charges.
Yes.
So charge on a proton is 1.6 in 10 to the power minus 19 coulomb, while that of electron is minus 1.6 in 10 to the power minus 19 coulomb. Sometimes we do not consider this negative sign while solving the calculation problems, numerical problems. Sometimes we skip this negative sign, because this negative sign only tells us about the polarity, or the a different nature of the charge on electron and proton, right? So we have already discussed this. अगर एटम को इलेक्ट्रॉन को लूज करेगा तो वो पॉजिटिव हो जाएगा, गेन करेगा तो वो नेगेटिव हो जाएगा, राइट? दिस वी हैव डन. सो द क्वांटिटी ऑफ चार्ज डिपेंड्स अपॉन द नंबर ऑफ एक्सिस इलेक्ट्रॉन्स और एक्सिस प्रोटॉन्स present in the object, as we have already discussed that in an object there are both protons and electrons present, but if an object has more number of protons than electrons, then it is positive. If it has more number of electrons than protons, then it is negative. So now on this basis we are going to solve few questions. So look at the screen, there are two questions. You can see on the screen, an object contains 8.25749 10 to the power 17 protons and 5.26 10 to the power 14 electrons. Calculate the charge on the object. Now we know about the charges. We know charge on proton and electron, they are equal, right? So you can see that we have more number of protons than electrons here. It is of the order of 10 to the power 17 in protons, and here the order is 10 to the power 14. So first we'll make the order same so that we can subtract and get the excess protons it carries.
Don't we just add the 2 and multiply it by the charge?
We'll multiply later on. First, we need to find the excess number of protons present in the object. Only then we can multiply it with the charge, no?
Oh, okay.
See, suppose I have 5 protons and 3 electrons. Let's make it simpler. I have 5 protons and 3 electrons. Then how much extra charge do I have? I have more protons than electrons, right? 2 protons extra I have. Then the object has plus 2 proton charge, right? So plus 2 into charge of 1 proton. This is how we are going to do.
So we are going to subtract the protons from electrons, and then we're going to multiply by the charge.
Yes.
Okay.
This is how we'll do it. So first we'll make the order of the number same so that we can easily subtract them. Because number of protons, it is of the order 10 to the power 17, while that of electron is 10 to the power 14. So first we need to make the order same.
It's not a big deal here because I can just do it on my calculator, so that's fine for you.
Find the answer.
Okay, yes. 0.132.
Yes, that's correct. 0.132 Coulomb.
Yeah, Coulomb, sorry.
So now let's try the next question. The amount of charge carried by a lightning bolt is estimated at 10 Coulomb. What quantity of excess electrons is carried by the lightning bolt? See, we need, there is one question that how many electrons are present in 1 Coulomb of charge. So do you know the number of electrons present in 1 Coulomb of charge?
No, I don't.
You don't know?
I don't think so. That is in my study design.
See, it's not there.
It's not there yet?
Yes.
Did you?
See, the formula is Q is equal to Ne. And if I say that charge is 1 Coulomb, then how many electrons are present?
Do I have that formula? I don't think so. We do that formula. Yeah, I don't think so. We do that formula.
This is very basic thing, right? And because sometimes we get questions where we need to use this formula. It is very simple and basic formula because charge is the number of electrons or protons present in the object, right? Because we are doing charges. So we can do it. So that इससे क्या होगा ना आपके concept थोड़े से clear हो जाएंगे. That's why I have taken this.
जी.
अगर हम थोड़ा सा उसी पे बुक पे ही फोकस रखेंगे ना तो बुक में कुछ आपकी है ही नहीं, कंटेंट ही नहीं है.
हाँ वो भी है. बुक में वो सारा मतलब बेसिक स्किप करके आगे बढ़ गए वो.
I have gone through the chapter, right? So they have skipped a lot of things. तो फिर उसमें ना आपको क्लैरिटी नहीं होगी, मतलब टॉपिक एग्जैक्टली आप पढ़ क्या रहे हो. आप चार्जेस पढ़ रहे हो, हम क्रैमिंग नहीं कर सकते. वी नीड टू अंडरस्टैंड द कॉन्सेप्ट, राइट? दैट्स व्हाई आई हैव टेकन दिस क्वेश्चन because it was mentioned there that what is charge and they had defined charge, but they can give you the questions based on charges like this.
जी मैम.
Okay, that's why we are doing it. So we can find the number of electrons. हाँ जी.
ये आपने Q is equals to Ne लिखा है ना?
हाँ जी, Q is equal to Ne. N is the number of electrons, E is the charge on 1 electron, and Q is the charge. Q is 1 Coulomb, right? Now we're going to find the number of electrons present in 1 Coulomb.
N is the number of electrons?
N is the number of electrons and E is the charge on 1 electron. So N is Q upon E. So 1 upon, we can learn this value. So we don't
Yes.
have to learn. We don't need to learn this, but we can learn this value as well, because so that we can use this directly. हर बार हम अपना कैलकुलेटर क्यों उठाएं?
जी मैम.
हर बार हम अपना कैलकुलेटर, every time we don't have to use the calculator, right?
जी.
Yeah. So it's 6.25 in 10 to the power 18 is the number. These are the number of electrons present in 1 coulomb of charge. Okay. Now we are
जी.
going to do the same question here, which is written here. Q is 10 coulomb, charge is given. And now we are going to find number of electrons, means we need to find n, small n. E is, the value of E we know. It is 1.6 in 10 to the power minus 19 coulomb. From here we
Yes.
can calculate it. The same way, the way we had done for 1 coulomb, in the same way we can do for 10 coulombs. So let's talk about properties of electric charge now. The first property is the quantization of charge, means charge is quantized. Only integral number of electrons can be transferred from one object to another object. We cannot say that half electron or 1.5 or 2.5 or 2/3 of electron. We don't speak like this. We say that 2 electrons have been removed, or 3 electrons or 5 electrons have been removed, right? So we only when we talk about electrons, we consider numbers only. N cannot be fractional, right? So this formula we
Yes.
have already used, that charge is an integral multiple of electrons. Second is conservation of charge, means charge is conserved. If we have two objects and we are rubbing two objects against each other, then one object acquires positive charge and other object acquires equal negative charge, but the total charge stays conserved. It stays the same. It will not change, right? It can only be transferred from one body to another.
जी मैम.
Characteristic of charge is invariance of charge, like mass and other physical quantities. There are certain physical quantities which that change with the speed. Mass also changes with the
जी.
speed. Mass is, it depends on the speed. M is equal to m naught upon square root of 1 minus v square upon c square. You might have used this formula. This is relativity. Have you read about relativity, special theory of relativity?
नहीं, वो हम लास्ट में पढ़ेंगे.
वो हम लास्ट में पढ़ेंगे.
मतलब हमारा करिकुलम लास्ट में है.
Okay, fine. So in relativity, we talk about, the object moving with the speed comparable to speed of light. So if something moves with a speed comparable to speed of light, then there are certain quantities that change. For example, mass, length, time. Okay. Have you seen the movie? Have you watched the movie Interstellar?
जी.
Interstellar में the man goes to the space and उसमें उसका जो aging है वो नहीं होता, right? So time dilation is the thing, right? That's time
जी.
dilation. And length contraction. If we see a train moving very fast, then we cannot exactly, मतलब हमें समझ नहीं आएगा उसका exactly कि length क्या है उसका. But if the train is there at the station, then we can easily tell about the length of the train, right? And
जी.
mass also changes with velocity, with speed. If an object is moving, then it has different mass when it is at rest. But charge is invariant. Invariant means it does not depend upon the speed. If the charge at rest is 5 coulomb, even if it is moving, the value of the charge remains the same, 5 coulomb only. Okay. So it is independent of speed. It is independent of speed. It does not depend on speed. This point we know that unlike charges attract and like charges repel each other, and charged objects attract neutral objects, as we have done already. Charge is a scalar quantity. It is not a vector quantity. And for an isolated system, if you are going to find the net charge on an object and there are number of charges present, then we just have to, add the charges. The algebraic sum we take. We do not take the vector sum. We add them algebraically. The simple algebraic sum that we usually, do. 1 plus 2 plus 3 like this. Okay? So if a system carries n number of charges, then we add the charges to get the total charge.
Okay. मैं लिख लूँ इसको?
Yes.
Can a body have a charge? ये किस चीज का charge है?
See, it is in decimal, but that's not the problem. Decimal is not the problem. But what is the charge on 1 electron?
It is 9.1 times
That's mass.
by
That's mass
no
of
1.6.
electron.
1.6 times by 10 to the power of -19.
Yes. So question is, can a body have a charge of 0.8 10 to minus 19 Coulomb? Answer is no. We can prove it mathematically using the same formula Q is equal to NE, because charge is given and we know charge on one electron. So from here we can find number of electrons. N cannot be fractional, but here we are getting a fraction. So we cannot have half
Okay.
electron on an object, right? We can either have 1 or 2 or 3 or 4 electrons like this.
Ji. Let me just take a screenshot of this one. Yes, let's move on.
Next topic is charge interactions. We have questions based on charges here. Can two likely charged balls be attracted to each other?
Can two likely no?
They can.
Likely charge?
Yes, if the charge on one ball is much greater than that of the other, the force of attraction caused by induced charges may exceed the force of repulsion. Now, what is this force of attraction caused by induced charges? Charges induce हो रहे हैं यहाँ पे. Induce कैसे हो रहे हैं? Suppose I have these two objects. Look at this. I have these two objects, right? This is a small charge and this one is bigger, right? So, and they have like charges. And I bring this object close to this object because it is positively charged. Here, within this object, separation of charges will take place. So negative charges will move towards this. Within one object, charges get separated. Still suppose this object is neutral object. Let's consider this is neutral object. And I bring a positively charged pen near this. What will happen? The negative charge present in this will move towards the pen because pen is positively charged.
Or to balance out the charges, yeah.
Pen is positively charged. So I have placed this pen close to the phone, and phone is neutral. Phone has, neutral means it has both positive and negative, but they are equal in number. Fine. Okay. Because pen is positive, so the negative charges present in the phone will move towards the pen. They get attracted to the pen, no? While the positive charges move away from the pen towards that side.
Yes.
So within the phone, charges get separated. That's called polarization. Okay. Polarization is not charging. It is just the separation of charges within the object.
Ji.
Charges get separated within the object, but still the phone is neutral because both negative and positive are there, but they are just separated. So because of that, the charges are induced. No? Induced charges may exceed the force of repulsion. Next, do the electrons and neutrons have like or unlike charges? Electrons are negatively charged while neutrons are neutral. So they are like or unlike?
What do you mean by like or unlike?
Like means whether they are both positive or both negative. They are similar or dissimilar.
They're not similar. Unlike.
Electron is more negative than neutron, and neutron has no charge on it. Why do we say that repulsion alone is the surest test of electrification? Have you understood?
No. Why?
Surest test of electrification means that if I have a charged object, ठीक है, तो हम ये ऐसा क्यों बोलते हैं कि रिपल्जन से ही हम चेक कर सकते हैं कि ये ऑब्जेक्ट चार्ज्ड है या नहीं है, अट्रैक्शन से हम चेक नहीं कर सकते. This mouse is charged. But why
because
that repulsion alone is the surest test?
Oh, yes, I get it. Because if it's neutral, then it will be attracted to a charged particle. That's why.
Oh, because both neutral or oppositely charged particles, they get attracted. Yes. So we cannot say for attraction, but for repulsion, it is 100% sure that the object is charged.
Oh, yeah.
Right? Because only a charged body can get repelled by another charged body carrying the like charge. This cannot be said in case of attraction because an oppositely charged body as well as an uncharged object can get attracted by a charged object.
Yes. Okay, I get it.
Screenshot.
I'll take a screenshot.
Done? Taken?
Yes.
Next is charge distribution. Charge distribution means how charge is distributed in an object. The charge can be distributed uniformly like this, and
Yes.
non-uniformly as well.
Yes.
You understand this uniform and non-uniform, these two terms?
We from my book, I think I read about uniform and non-uniform with gravitational fields. How when it's non-uniform
Uniform
in a like
means charges are equally spaced. Here it means charges are equally spaced. They are properly
oh okay
distributed. जैसे soldiers march
okay
करते हैं ना, वैसे.
जी
And non-uniform
okay
means where there is irregular or discontinuity or irregular distribution of charges. Charges are not equally spaced. Where the surface
Mhm.
is more curved, we see more charges there. But the surface where the surface is less curved, there charges are very far away from.
Okay.
So more charges accumulated at the curved and sharp points. This is non-uniform distribution of charge, where there is uneven distribution. Uneven is the word. Uneven distribution of
Mhm.
charge. And in uniform, there is even distribution of charge.
Okay. I'll just
Oh, sorry. Yes.
it's okay.
Taken?
जी, we can move on. जी.
Next is charge density. Charge density, it is the quantitative representation of charge distribution. Density is mass upon volume, right? This is how we find density.
जी.
Mass present in a volume. Similarly, we can find charge density. Charge density is charge present in a volume.
Okay.
Please take the screenshot of the slide.
Yeah, give me a second. Yeah, I've done it.
See, we can also have linear charge density, surface charge density, or volume charge density. It depends upon the nature of surface that we have, right? So linear charge density is denoted by lambda. It is charge per unit length. For example, if I have a rod and of, we can say, negligible thickness, right? And it is charged, then we can find the charge per unit length present on the rod. So lambda, it is denoted by lambda, linear charge density. It is charge per unit length. Unit length में charge कितना होगा? अगर
We don't do it here. These are all new topics.
So it is Q upon 2 pi r for the circular ring, because length of the ring is 2 pi r, right? If we talk about the ring,
जी.
no? And
जी, जी.
so basically this is lambda, where we study a small portion of charge present in the small length, and then we get to know about the whole system.
जी.
Next is surface charge density. It is denoted by sigma. In the same way as we have done for linear charge density, here we consider surface, two-dimensional objects, like you can consider circle or square or rectangle or disk, right? So we can again find charge per unit area. Unit area में कितना charge present है? For example, if I take this tablet, यहाँ पे
जी.
ये पूरा charged है, ठीक है?
जी, मैम.
I'll take a small portion of it, small unit area of this, and the charge present on this unit area I'll find out first, ठीक है? और उससे मुझे आइडिया लग जाएगा कि कैसा सिस्टम है और कैसा नेचर है चार्ज का, डिस्ट्रीब्यूशन का, राइट? So
जी,
instead
मैम.
of studying the whole surface, I'll take a small portion of it and study it.
जी, मैम.
That's charge per unit area. इसको भी फटाफट निकालते हैं, ठीक है?
ये सिंबल क्या है, मैम?
सिग्मा.
सिग्मा.
हाँ, तो इसको बॉदर नहीं करना, बस इसको आपने निकालना है.
जी, मैम.
जैसे होता है ना कि हम कोई चीज सुनते हैं और खत्म करते हैं कि हाँ ठीक है, ये बस माइंड में, सबकॉन्शियस माइंड में बैठ गया, कभी जरूरत पड़ेगी तो
जी,
यूज
मैम.
करेंगे, नहीं जरूरत पड़ेगी तो ठीक है, पड़ा रहने दो उसको सबकॉन्शियस माइंड में, ठीक है?
जी.
नेक्स्ट इज योर वॉल्यूम चार्ज डेंसिटी. वॉल्यूम चार्ज डेंसिटी में वी कंसिडर द वॉल्यूम. हियर वी टॉक अबाउट थ्री डायमेंशनल ऑब्जेक्ट्स लाइक स्फेयर और क्यूब, ठीक है? तो चार्ज पर यूनिट वॉल्यूम फाइंड करते हैं. तो फॉर अ स्फेयर, वॉल्यूम इज 4/3 पाई आर क्यूब. सो विल पुट द वैल्यू ऑफ v here and get the rho. Rho, the symbol is rho, RHO.
जी.
ठीक है? तो ये आपका अगेन यूनिट वॉल्यूम में कितना चार्ज कितना है, मतलब अगर आपके पास एक बॉल है एंड बॉल इज चार्ज, तो वी टेक द यूनिट वॉल्यूम ऑफ दैट बॉल एंड वी कैलकुलेट द चार्ज ऑन इट, dq by dv निकाल के वी गेट टू नो अबाउट द चार्ज डिस्ट्रीब्यूशन ऑफ द होल बॉल।
जी।